All right, so for elimination, the goal of elimination is the following. Here is our goal. Your goal is to get to have opposite coefficients. For x or y. Again, that's the goal, and I'll explain what that means. It's very simple once you see an example. But our goal is to have opposite coefficients for x and y. And what that means is this. The coefficient for x here is 3. So I really want this coefficient here to be negative 3. Again, this coefficient is 3. I want this one to be negative 3. This one is 4 here. So I really want this one to be negative 4. And there are certain times you can do it and certain times you cannot do it. And we'll go through those examples. But again, I want the x's to have opposite coefficients. Or is the key word, not and, but or, it doesn't matter, either one. Or I want the y's to have opposite coefficients. Okay? Where are you at? Coefficients. Coefficients. So, if I look at this setup and I want opposite coefficients, does anybody see one way I can do this? Melissa?
You could multiply the whole thing, like parentheses, and then multiply by something that's going to have the opposite of the top.
Absolutely. So give me the more specific example. Which one would I do?
The bottom one, you can multiply the whole thing by negative.
Okay. So Melissa's saying if I multiply the entire equation by negative 3, multiply everything. There's a 1 here. There's really a little 1 there. There's a 5 there, and there's a negative 7 there. Multiply all those by negative 3 and write the other equation down. So again, multiply all of these by the negative 3. So distribute the negative 3 to every part of the entire equation. The entire equation, not just the left-hand side. You need to do to one side the same to the other. So if I multiply negative 3 times 1, I get negative 3x. If I multiply negative 3 times 5, I get negative 15y. And here, negative 3 times negative 7, positive 21. Negative, negative, positive 21. Now, take a look at equation 1 and look at the new equation we have. Look at the x's. Don't they have opposite coefficients? Opposite coefficients?
Yeah.
We've attained our goal. At this point, just list them together, and you're going to see what happens. So list the first equation, 3x plus 4y equals 1. List that with the new equation over here. So I don't care about this one anymore. List it with the new one over there. Now at this point in time, take a look. You see that your x's are opposites. They are opposites. There's a technique you learned in Algebra 1 a while back that says that you can simply add everything together. Just add straight down the columns. What happens to the 3x and the negative 3x? So what does it become?
Zero.
Just 0. Just 0. Be careful. Again, this is like 3 apples, and I've eaten all 3 apples. Do I have any left?
No.
Okay? I ate them all. So, the 4 and the negative 15, what do these become?
11.
Negative 11.
11.
And what does this become?
22.
22. Okay, 22. Again, all we're doing now is literally going like this. Okay? Just add straight down the columns once you have opposite coefficients. You cannot add these columns together until you get opposite coefficients, though. So we couldn't add them together in the beginning. It wouldn't work because we need something to be eliminated. Again, the goal is to eliminate a variable, hence the name elimination.
Do you always add?
You always add. You always get opposites and then you add.
You solve for
Okay?
y.
And then solve for y. If you have this, what is it? Negative 2. Divide by negative 11. Divide by negative, there's an equation. We get y equals negative 2. Well, I need x also, so what do?
Plug it.
Good. So plug it back in. Now, in this case, it doesn't really matter where I plug it in. Nothing is really as simple as it looks. But without all this stuff up here, you can see a little more clearly. Out of the first 2 equations, which one would you probably plug in the y value for?
The first one. No, the second
The
one.
second one?
I can't.
Which one?
It don't matter.
Okay, if I plug in, we said y was negative 2, right? So I can plug a negative 2 in, right up here for that y value and then solve for x, or I could plug it in here and solve for x. One of them is easier than the other. Why, Kelly?
Because x is already by itself.
Good. Isn't the goal, we got y. Aren't we trying to get x now?
Yeah.
And x is already by itself over here. So if you could plug in the y here, in this part, and then move it over, it's a lot easier. It doesn't matter though, again, it makes no difference which way you do this. So y is negative 2, so I'm going to plug in a negative 2 right here. I'm going to get x, this is plus, what's 5 times negative 2?
Negative 10.
That's what I get when I plug in the negative 2. Again, I'm taking my answer from down here, plugging it in right there. Add 10 to both sides because it's a negative 10. X becomes 3. Again, so this is a negative 10, add 10, negative 7 plus 10 is positive 3. So since x is 3 and y was negative 2, our answer is right here, 3, negative 2. Okay? Again, 3, negative 2. Andy, please pick your hand up. Tap your hands. So x is 3 and y is negative 2. Focus, sir. Come on.
You did five.
For which one? Right here, how do we get the 3?
Yeah.
To get the 3 here, we had x plus negative 10 equals negative 7.
Also, you did.
Add 10 to both sides. 10 and negative 7
3.
gives you positive 3. Okay? Again, this is a problem where it's given already. This is an easier version, just because you're already given the equations. Now let's go take a look and see what happens now if we have a word problem. Okay, the word problem gets a lot more complicated. Now, take a second to read it. Take a second to read it, and I'm going to try and go over something that might simplify it a little bit. I know some of these words are confusing. This is just an SAT problem that I pulled. It looks confusing right away. We'll break it down.
Like 2 minutes after the quiz.
Okay. What was the jet speed?
First, we got to start with, does anybody know what a jet stream actually is? And it's not the stuff that comes out of a jet.
It's a wind. It's a type of wind.
It's wind. Thank you. Nobody knew that third period. And that's random. You know, I don't expect you to know it, but it's on the SAT. Okay? Good job, John. So, in the direction of the jet stream, or in the direction of the wind. 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 Okay? So right away, the hard part about this problem is that a lot of people don't know what the word jet stream is. The jet stream is the flow of the air, of the natural current flow around the globe. So if the jet stream is running like up the North Atlantic coast and stuff, there's a current to the actual flow of fluid around the earth. So like even the water of the ocean, there's a certain flow that it follows throughout the entire ocean. Like from the Pacific Ocean into the Atlantic Ocean through some canals, there's a certain way the water is flowing. Jet stream is the air and the way the air flows. That's why flights sometimes, you don't always take off here and go directly here. Sometimes you fly in this direction because the flow of the air might be in that direction, so it helps you. So the shortest distance happens to be this, but you might flow that way, you might flow that way, you might flow certain directions change when you're on certain flights. Okay, based on the way that the air is flowing. Kelly, get a hand.
Yeah, like on the SAT, are they gonna write questions like that?
This is an old SAT problem.
Oh my god.
So I'm just trying to get you guys the idea of what it could be.
I'm gonna have a student ask for whoever's
No. I can't ask any questions on the SAT. The proctor cannot answer any questions on your SAT. Yeah, it's tough, I know. I'm just trying to give you guys a little preview so you know. Again, so jet stream means wind though, so we know that. Now, what is the problem asking? That's the first thing we have to think about. Remember yesterday we talked about let statements? We need to do let statements here. But I need to know what I'm being asked before I can even write let statements.
It's jet speed. The wind speed.
The wind speed and what else?
And
The jet speed.
and the jet speed in still air, the jet's speed. So, I am being asked to find the jet speed and the wind speed. Those are the things that are being asked. Therefore, those are my variables automatically. Again, if you're asked to find the jet speed and you're asked to find the air speed or the wind speed, that's what x and y are. Okay? So start with x is the speed of the jet. Now, if you don't know the word jet, think of plane. Same thing. Y is the speed of the wind. Okay, so we've written our let statements. That's the most important part of these problems. If you can't do that, you can't even start this problem. Okay, there's no way to do this unless you actually start writing your equations out. Now, at this point in time, I'm going to draw a little image, just so you guys can see what I'm thinking about. It says, I'll try and draw a plane. It took 3 hours to fly 1,800 miles in the direction of the wind. Okay, I'm walking down the road, it's a cold day. Say you're walking, who takes the bus to school? Okay, so you walk from the bus stop, right? So some days the wind's at your back,
Yeah.
and it helps you along, right? But some days what?
This was against.
It's pushing you back, right? Have you ever gotten to the point where you can really feel it, right?
Yeah.
You can really feel the wind pushing you either forward or backward. That's what this means. On the way there, it takes 3 hours to fly 1,800 miles in the direction of the wind, meaning with the wind. The wind is helping it. On the way back, it takes 4 hours because the wind is acting against it. So it takes longer, which is logical. Think about it. If a plane is flying with the wind, it'll take less time than it's flying against. When the wind pushes against the plane, it applies resistance, so it slows down the plane. So now we want to think about this. If I was walking down the road, okay, and I'm walking at 3 miles per hour, very slow, 3 miles per hour, and then a wind comes along and pushes me, and the wind has a force or magnitude of 2 miles per hour. I'm walking at 3, the wind pushes me at 2, 5 miles an hour. Again, think about it this way. I'm walking this way, and then the wind also happens to be pushing this way. I would add those vectors together. I would add sorry, I don't, you ever heard vectors before or no? Physical science?
Yeah, like the
We get
little,
what you're saying.
like
The direction and magnitude of the force. Very good. So the idea is that the person is pushing this way.
Like, yeah.
No, I did get it.
Sure.
She didn't say anything.
And the wind is that way. So on the way there, that's the jet, and that's the wind. On the way there. That's our first scenario. On the way there. But on the way back, the wind is still acting to the right. The wind is still acting this way. But now which way are you flying?
Going that way.
Going to the left.
Yeah.
So this is opposing your motion, isn't it? So again, this is helping me along. This is not helping me along. So back to my example. If I'm walking 3 and the wind is pushing another 2, I'm at 5. But if I was walking 3 and the wind was pushing back at 2, what would it be at?
You said what?
Again, I'm walking 3 and the wind pushes behind me with 2. I gain 2 miles an hour, I get 5 miles an hour.
Okay.
But if I happen to be walking this way, 3, and the wind is pushing 2 this way, what am I really walking? At 1. How did you get that one?
Because you subtracted.
Okay, so we subtract and add. We agree with that?
Yeah.
Okay, keep that in mind. It's going to come into play. Next. This kind of a problem has to do with, obviously, distance, time, and speed. Remember, your formula from velocity or speed equals distance over time. Very good. This is our formula for physical science. This is a formula that you do want to memorize even for math. It comes up a lot on the SAT, and they don't give you the formula. This just means the rate of change is the distance traveled over the time. Now, in this problem, what distance do we travel? What did it say? How far? 1,800 miles. Now, Karen, if I travel there 1,800 miles, and then I come back, how far do I go on the way back?
The same.
The same, 1,800 miles. If I walk across the room, and then I walk back to this spot, I'm walking the same distance. Unless I take a different path, obviously. Right? So let's say I just walk directly to the door, and then directly back. Back. Same distance in both directions. Both and back. Now, so my distance is 1,800 no matter what. On the way there, how long did it take? What did it say?
It said 3 hours.
But on the way back, how long did it take?
4
4 hours. Okay? So let's take a look at our two scenarios now. We've got, on the way there, It was 1,800 miles, and it took 3 hours. I'm going to leave the V blank for now. On the way, I'm using this formula here. I'm using our V formula for both of these. On the way back, it was still 1,800 miles, but how long did it take? 4 hours. Now, on the way there, was the wind helping me or pushing against me? It was helping. It was helping on the way there. So I have the speed of the wind plus my speed together, right? So my speed was x, the speed of the wind was y. And I say my speed, I mean the speed of the jet, obviously. So my speed, x, plus the speed of the wind, because on the way there they acted together. But on the way back, what happened to them? Because they acted what? Against one another. So again, the speed of the jet and the speed of the wind together took 3 hours to go 1,800 miles. But the speed of the jet minus the wind speed, so we're losing speed now because of the wind, that took 4 hours. And that's logical. It should take you longer because you're going slower. At this point, you have two equations, two variables. You have to use the elimination method. What's 1,800 over 3?
600.
Very good, 600. 1,800 over 4? Half would be 900. Half of that is? Half of 9 is?
3. Half an hour.
4.5.
4.5. So this is 450. You can think of it, half of 1,800 is 900, half of 900 is 450. Take a look at these equations. It's very simple to solve them using elimination because of the opposite y's. Wasn't our goal for elimination to have opposite coefficients?
Yes.
And the y's are opposite, so just add these equations together. Okay, line them up and add them up. Okay, add the x's. What do you get?
0.
X's.
X to X.
Thank you. The y's. Okay, divide by 2. You get 5. What is it? And then divided by 2, what do you get? What do you get with the speed of the jet?
525.
525, good. Think of half a thousand as 500, half of 50 is 25, 525. Now, that's the speed of the jet. We have to make sure we state that, because we're not looking for x, we're looking for the jet, so we have to make sure we write that. Well, I want the other one too, don't I?
Yeah.
Where?
Whichever.
Yeah, this time it makes no difference,
How'd you
right?
get 2 X?
does it? No, because they X's are.
How'd you get 2 Y?
These are opposites, aren't they? They cancel.
Yeah, you can do one.
So this 525 needs to go in either right here or right here. It doesn't matter. Pick either spot, you get the same answer.
That one, that one.
That one? Okay.
Yeah.
So 525 plus y equals 600. Subtract 525.
75.
Very good. So if y is 75, that means the wind speed was 75.
Miles per hour.
Miles per, whatever the units were in the beginning. I think we started with miles per hour. And that's logical. This is the actual speed of a jet. Planes, when you fly on, if you fly like even domestic, even in the U.S. or international, they fly about 500 miles an hour.
Bro, it doesn't feel like it.
Doesn't feel like it. You know why? Because they're flying at a constant velocity when there's no acceleration. When you're in your car and you feel like those jolts in the car, when do you feel that? When you hit the brake, right? Or when you nail the gas? Because you're accelerating or you're decelerating. You remember F equals ma?
Yeah.
The force you feel is proportional to the acceleration. So if there's acceleration, you feel that force. But when you're flying in the air, they put it on cruise control. And they put it at 500 or whatever the speed is, and they leave it that way. So you don't feel any acceleration. If there's no acceleration, then there's no force. They're both
What I'm
zeros.
saying, you look at the clouds and it's still.
And it just looks like you're just consistently like coasting by, right? Yeah. Same thing, like think about it this way, guys. If you're in a train underground, if you're in a train, and you happen to be, let's say all the windows in the train are all blacked out, and you have lights on, but you can't see outside the train. If you're moving at a constant velocity, and you have, imagine you have no sound, you wouldn't even know you're moving.
That's true.
Because you don't feel it. You only feel when you brake or when you accelerate. That's all you feel because of Newton's second law. Or third law? First law? Doesn't matter which one. One of his 3 laws. But it's true. Doesn't matter which one you call it. 1, 2, or 3. Doesn't make a difference. Equal and opposite, inertia, and F equals ma. Those are the 3. Does not matter the order. Now, you don't feel it. And there's always a constant theoretical problem where it says like this.
It would, but no.
if you happen to be passing somebody else, and you're in one train and they're in the other train, it looks like they're moving, right? And for them, it looks like you're moving, but who's really moving? You might not either be moving. One of you might be moving. You don't know because you're moving at a constant velocity. Until you feel acceleration, then you know if you're moving or not. Just a little physics thing. Anyway, so the jet speed, 525, the wind, 75. Okay? Let's go to the next problem. Another word problem. Yes.
Are these type of word problems going to be our midterms or our test?
This is the kind of problem you'll see like this one right here. That last one with the jet stream would be like the hardest one you'd see on the even on the SAT. That's a very tough problem for SAT.
Okay.
Okay? That would be definitely a difficult level problem. This next one here is medium to difficult. Okay? It's a little tough, but once you do this kind of problem enough, it gets a little easier. Now, in your homework tonight, you're going to have a problem with basketball players with 2 points and 3-point shots. This example is pretty much the same thing, but now we're looking at 2-point problems on the test and 5-point problems. No difference, okay? Same thing with like football, an extra point versus 2-point conversion, 1 and 2-point things. That's what this is really, okay? And you're going to see tonight when you look at your homework, you have that. So we have an exam that's worth 145 points, and there happen to be 50 problems on the exam. Some of the problems are worth 2 points, some are worth 5 points. We want to know how many 2-point problems are there and how many 5-point problems are there. Okay, again, you're trying to figure out how many 2-pointers are there and how many 5-pointers are there. So if somebody was playing in a basketball game and they had a total score of like 35 points, and you wanted to know, well, how many 2-pointers did they make and how many 3-pointers, assuming there were no foul shots maybe. Okay, you would need some other piece of information. You need to know that maybe they had 25 baskets altogether, and then you can figure it out, or 12 baskets altogether. So we need some information. So the information that we have pretty much is all right here in the first sentence. That's all the info we have. Everything else is the question. So we need to start with our variables, our let statements. What are we being asked to find out?
How many questions?
How many questions of?
2 points.
And how many questions of?
5 points.
Good. So again, we are figuring out how many 2-pointers, how many 5-pointers. So let's X equal the number of 2-point questions, and then Y would be?
Number 5.
5-point. Very good. Again, your let statements always answer the question. They do. It says, how many 2-point questions are there? Well, X is the number of 2-point questions. How many 5-pointers? Y is the number of 5-point questions. Okay? Now, the first sentence is the hardest part to deconstruct, to figure out what to do with. So I've got this thing where it says the test is worth 145 points. There's that fact. And then there's also 50 questions. So I need to use both of these because clearly I have 2 variables, so I will need 2 equations here. Again, I have 2 variables, I will need 2 equations. X tells me the number of 2-point questions. Before I actually go into this problem, let's do a hypothetical. What if there were 15 of these problems? If there were 15 2-point problems, how many 5-point problems would there be then?
35.
35. And yes, that's the idea there. So we know that 15 and 35, how come? What do they add up to? They add up to questions. They add up to 50 questions.
Yeah.
Okay, not 145. That's points. We'll do that in a second. So no matter what, these will always add up to 50. If there were 20 of these, there would be 30 of these. 20 of these, 30 of these. 20 and 30, still 50 questions. So altogether, the number of 2-point questions and the number of 5-point questions is 50, isn't it?
So X plus Y equals 50.
There it is. Again, let's go through this. It's why it's tough in the beginning when you see these. The number of 2-point questions, X, plus the number of 5-point questions, Y, is 50. There are 50 total. When it says total, it means sum. When you hear total, add them up. Okay, just like we had the question with Jim and Sam's money yesterday. It said their money added up to like $70 or something the other day. So we summed them together. Same thing. Kelly.
I know that like it has to be logic, but like how do you know which numbers to start with? Like in the word problem. Like how do you know that it was supposed to be questions and not points? Like
Well, we use both. I was just picking questions.
oh, so you can start with the 145.
Sure. Now we'll do 145 next. We need to use that still.
Oh, okay.
Because look, we only have one equation, right?
Yeah.
And 2 variables. So we still need another equation.
Oh.
That's where the 145 is going to come in.
Okay.
Now, here's the tough part. Okay, you know already?
No, what did you get?
total number of questions. X is the number of 2-point questions. Y is the number of 5-point questions. Total, it said there were 50 questions, right? So if I add together the number of each problems, so if there are 20 of these and 30 of these, I get 50. So X and Y together, the amount of questions of X, the amount of questions of Y is 50. Okay? Now, the next part is more difficult. So I'm going to give you a hypothetical before we get to this problem. Let's say you took a test, and there are problems, each problem is worth 3 points. Every problem is worth 3 points. And there were 5 problems on the test, and you got 4 of them right. You got 4 right, and there were 3 points each. How many points did you get?
Oh,
You got 4 right, and there were 3 each.
4.
Leslie?
12.
12. Again, you got 4 right, every problem is worth 3 points, you multiply them together, you get 12 points.
12.
Okay? So you took the number of points, multiplied by however many you got right. Agreed?
yeah.
Okay, so if there were 20 problems you got right, and there were 2 points each, how many points did you get? 40. Again, 20 problems at 2 points each, you get 40 points. So we're multiplying the number of problems times the point value. The number of problems, Melissa. What would you do here?
2x plus 5x equals 145.
5y, you mean, obviously.
Oh, sorry.
That's all right. Again, X is the number of 2-point problems. Well, this is however many there are times 2 points each. However many there are times 5 points each equals a total of 145 points. Again, these are worth 2 points per problem. X is however many problems there are. This is worth 5 points per problem. Y is however many problems there are. A total the test has 145 points on it. So now I've got 2 equations, 2 unknowns I can solve. Okay? This kind of a problem is a little bit difficult because of the setup. Once you get to here, use your elimination method. You see that there's a 2 here, don't you? So make this a -2 by multiplying everything by -2 up there. And then see what you get.
So would you like minus 5y?
You could do that whole process and get substitution method, but we're doing elimination today. So don't go through all that work. Okay, you could subtract y. So you could subtract y here, subtract y and get x equals 50 minus y, then plug it in. But it's a lot easier to do this. Multiply this entire equation by -2 and rewrite it below it. Multiply the entire equation by -2. You'll get -2x, -2y equals -100. Again, multiply the entire red equation by -2 and you get the blue equation.
Do you have to multiply by -2?
What else could you have done? There's one other thing to do.
Add?
What is the goal, Eddie? You want opposite coefficients, right? Remember that was the goal? So if I didn't want opposites here, what could I have done over here instead? What would the coefficients have been here to get opposite? Instead of -2, what's another number I could have multiplied that would get rid of the y instead of the x?
Oh, where did you get a honeycomb?
Instead of getting rid of the -2 here, right? I would want something here instead that would get rid of this. So what instead of -2 should I put so that these are now opposites?
Minus x minus 5.
Say again?
X minus 5.
Not x minus y. Somebody help them out here. Do you understand what I'm saying, everybody?
Yeah, you multiply it by -5.
How can you explain that to them?
Because you know how you got the opposite of like the 2. You know how 2x is the opposite of -2x.
These are
You see
opposites?
that, right? Okay. So we did that because we wanted them to be opposite. We multiplied it by -2, right? So then you see the y, right, by itself. So if we wanted to get the opposite of the 5y, we would have to multiply it by -5 to get the opposite. You get it?
So if we had done, we could have also had done this, guys. We could have also had put the -5 there. Okay, that would have made everything 5s, Eddie.
Oh, she was
Okay? Ed, thumbs up, down, maybe, medium?
Yeah, she helped me.
Okay. We'll talk about it after, just don't know. So the 2x's, what happens to them? Add it down, guys.
Oh.
0, they drop off, right?
Yeah.
So it's back to x minus y?
What happens here?
3y, 45.
Add down.
Oh.
This is why I told you to wake up before, sir. It's alright. Glad you're up now.
And then it's 15, y equals 15.
Y is equal to 15 here, very good.
And then you plug it in, and then x is 15.
Now, take a look. Here, once you get to 15, you know there's a total of 50 problems, aren't there?
Yeah.
So you know the other one's going to be 35 automatically. Now, what did X represent in the very beginning of the problem?
2-point questions.
2-point questions. So there are 35 2-point questions. There are 15 5-point questions. That's your final answer right there. Now, had we chosen to get rid of the Y instead, if we had chosen a -5, it would have done pretty much the same thing. We would have gotten X first, and we would have gotten X equals 35, and then we plug that back in to get Y. So it doesn't matter which way we choose to do this. But again, the idea is so you can cancel this. You want to have opposite coefficients. That's the whole goal today. Get opposite coefficients, and you're good to go from there. Now, your homework tonight, you have 6 word problems to work on. Okay, there are 6 word problems. You have the weekend. I do expect them to all be done. Please do not just give up if you don't get something. Remember, let statements first. Look at what is being asked. Your let statements are always the answers of what is being asked. If it says, what did a cheeseburger cost and what did a fry cost? Your X is the cost of a cheeseburger. Y is the cost of an order of fries. Okay? If it says how many 2-point shots and 3-point shots were there, X is the number of 2-point shots. Y is the number of 3-point shots. You're always answering the question being asked. Okay, there was something else.
Are they always opposite?
You're trying to.
What do you mean opposite? Help me out.
Like, since you said like, it's like 2-point shots are like different and 3-point,
3-point, yeah.
yeah, 3-point shots are different. Like, are they supposed to be opposite? Like Y equals Y don't be equal to 2.
And X the other one? Sure, yes. Yes. That's where the variables come. I think that opposite is a negative opposite. Not negative, though. One is one is the other.